For do now number 1 for chapter 4, we're going to do 2 separate problems, and the first one is to complete the statement, and it's asking which line segment is parallel to XY. So again, this is from yesterday with the mid segments of your triangle. So here's XY, and again, that's going to be parallel to the side that's directly opposite that, which in this case is going to be BC. Okay, for number 2, we want to solve for x. And again, the fact that these have these marks here means that this point and this point are both midpoints. So that makes this line a mid-segment. And again, if that's represented by 2x plus 1 and this one equals 18, if I multiply this one by 2, I should get that 18. So the equation that I'm going to write for this is going to be 2 times 2x plus 1 equals 18. We'll distribute that 2 on the left-hand side. So I'll have 4x plus 2 equals 18. Subtract 2 from both sides, and 4x is going to equal 16. Divide both sides by 4, and x is going to equal 4. It just asked me to find x. I found it. I don't need to do anything else. So the goal of today is to do section 4.2, and 4.2 is perpendicular and angle bisectors. Okay, and again, keep in mind that there is no quiz in this chapter. So a perpendicular bisector. A perpendicular bisector is a line that intersects another line at its midpoint, forming right angles. So given that CD is the perpendicular bisector to AB, the conclusion would be that angle CDB and angle CDA are right angles, and that D is the midpoint of AB. So again, you can see that we have the 2 congruent pieces here, making that the midpoint. And again, that's denoted as your right angle, and also that is going to be your right angle. The perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment, and conversely. Okay, so in other words, again, if you have this would be your perpendicular bisector here. Again, how do I know that? There's the perpendicular sign, and those two things are equal, making it the perpendicular bisector. So the conclusion is that this side is equal to this side. Okay, and again, you can go the opposite way and say, if you know that this side is equal to this side, and then you drop your perpendicular bisector, you would have your 2 congruent pieces on the bottom. So our examples here, we want to find the length of AB. And again, this BD is the perpendicular bisector. Again, perpendicular, there's your right angle marker. Bisector, because those 2 pieces are equal, which means that this side is congruent to this side. So as an equation, I'm going to set 6x minus 10 equal to 4x. Subtract 6x from both sides, and negative 10 is going to equal negative 2x. The opposite of multiplying by a negative 2 is to divide by a negative 2. And that means that x is going to be equal to 5. Okay, this time, unlike previous problems that we've done, this one is actually asking you to find the length of AB. So now I need to go back and plug that x into 4x. So AB is 4 times x, and we just found out that x was 5. So 4 times 5 is 20. So the length of AB is 20. For number 2, we want to find the value of x. And again, this time they told me that this side was equal to this side, which again would mean that this piece has to be equal to that piece. So again, we can just set 17x minus 3 equal to 9x plus 13. I'll subtract 9x from both sides first to have 8x minus 3 equals 13. The opposite of subtracting 3 is to add 3. And 8x is going to equal 16. Divide both sides by 8. And x is going to equal 2. This time, unlike the problem before, it only asked me to find x. I've found it. I'm done. Okay, so now an angle bisector is a line that divides an angle into two congruent angles. So given that AP bisects angle BAC, that means that angle BAP is going to be congruent to CAP. So again, AP is the bisector there. And again, this is going to be congruent to this. I have no idea why my doorbell just rang. Sorry, if I stop, I have to start this over from the beginning. So we're just going to wait 1 second. My dog does not like when the doorbell rings, obviously. Okay, so, and again, the opposite thing is going to happen, the angle bisector theorem. If a point is on the angle bisector, then the point is equidistant from the sides of the angle and conversely. So again, if I can tell you that this angle is equal to this angle, that means that DB is going to equal DC. Okay, so again, if this angle equals this angle, this piece is going to equal that piece. Okay, so our last two problems here. What is the length of RM? Okay, so RM is represented by 7x, and our other piece is represented by 2x plus 25. So again, if we're told that these two angles are congruent, that means that this piece has to be equal to that piece. So I'm going to set 7x equal to 2x plus 25. Subtract 2x from both sides, and I'm going to have 5x equals 25. Divide both sides by 5, and x is going to equal 5. Didn't ask me to find x, though. It asked me to find the length of RM, so I need to take that x and plug that back in to 7x, or 7 times 5 is 35. Okay, and our last one, again, is the opposite. So this time I'm told that these two pieces are equal. If those two pieces are equal, that means that this is an angle bisector and that the two angles that I just put the blue marks through are going to be congruent. So we're going to set 8x minus 41 equal to 5x minus 11. Subtract 5x from both sides, and I'm going to have 3x minus 41 equals negative 11. And I'll add 41 to both sides, and 3x is going to equal 30. Lastly, we'll divide by 3, and x is going to equal 10. Again, it only asked me to find the value of x. I found it, and I'm done.